Hi guys, in this video I'm going to be continuing with the AP Calculus BC series. I'm going to be discussing the integral test. So let's get started. So it says that suppose for all x is greater than equal to 1, the function a of x is continuous, positive, and decreasing. And if we have k equals 1 infinity a of k and integral 1 to infinity a of x dx, this can be written as limit b tends to infinity, integral 1 to b, a of x dx. So this is what the integral test says. And then also we have to know that a of k equals a of k. Sorry, this is a of x. For the integers, k is greater than or equal to 1. And now what we need to know is if both diverge, so if one of the, let me explain again. So if one of the integrals, so for example, if the integral diverges, the limit, so does the other. And if the limit converges, the other one converges as well. But it won't converge to the same value. So now let me explain an example to help explain this topic further. So the question says that sigma n equals 1 infinity 1 over 3n plus 4. We have to find whether this converges or diverges, and we can use the integral test. So this can be written as 1 to infinity integral 1 over 3n plus 4 dx. Sorry, this is 3x plus 4. Now this can be written as limit b tends to infinity, integral 1 to b, 1 over 3x plus 4 dx. And now we can solve this integral. We get 1 over 3 natural log of 3x plus 4, 1 to b. And now finally, let's just plug in our bounds. So limit b tends to infinity, upper bound minus lower bound. So 1 over 3 ln 3b plus 4 minus 1 over 3 ln 7. We know that ln of infinity would just basically be infinity, so we get our answer as infinity, as it's still a very large number. Therefore, the improper integral diverges. Integral diverges. So, because the improper integral diverges, our series diverges also by the integral test. So this is just a simple explanation of the integral test. So we found that the improper integral diverges as it's equal to infinity. Therefore, the series also diverges. Now let's look at another example. The example states that we have to determine whether this converges or diverges, 1 over n cubed. This becomes integral 1 to infinity We can leave it in terms of n if we need. So 1 over n cubed would be dn, and this would be limit b tends to infinity, integral 1 to b 1 over n cubed dn, which becomes limit b tends to infinity minus n to the power of -2 over 2, 1 to b. Finally, our last step is to just plug in the bounds. So we get limit b tends to infinity -1 over 2n squared 1 to b. So this can just be written as this, as we're basically taking the numerator down. Finally, we plug in the bounds and we get -1 over 2b squared minus or plus, it becomes plus because we have two negatives, plus 1 over 2. And now, if we plug in infinity to this, we get 0 plus 1 over 2, which is 1/2. So the improper integral converges to 1/2. Because the improper integral converges, our series also converges. So our series converges. But it's important to note that our series does not converge to 1/2 necessarily just because the improper integral converges to 1/2. It could converge to another value, but we just use this integral test to determine whether it converges or not. So that's how easy it is. And that's what the integral test is. Okay, that's it for today's video, guys. In today's video, I discussed two examples of the integral test and also explained how it's carried. Hope you all have a great day and please consider liking and subscribing. Thank you.